This is the problem pack. Question 7, 8, and 9. Kyle is flying a helicopter when he drops a bag or a wallet or whatever. A coffee crisp chocolate bar. It makes no difference what he's dropping. When the bag has fallen 2 seconds, what is the bag's velocity and how far has the bag fallen? Maybe it's his lunch. There's his lunch bag, and it's fallen. It's giant. He's a big guy. He's got a lot of lunch. Okay? The time is 2 seconds. What is the bag's velocity? So we are asking to find the final velocity after that 2-second interval. What is the initial velocity? 0, because it's dropped. Now, it doesn't say anything about this helicopter rising or falling. You can only assume that it's sort of just hovering there, right? So what is the bag's velocity? Well, what do we know? We also know the acceleration is minus 9.8. So I know the acceleration and I know the time. And I know that one formula that has those in it is A is equal to delta V over delta T. Which means that our change in velocity is minus 19.6 meters per second. The speed changes by minus 19.6. What's that? That is also the VF. You're right, Jason. I hadn't got there yet. You're a little bit ahead, but delta V is VF minus VI. Minus 19.6 equals VF minus 0. Which means that the final velocity is 19.6. And as always, the delta V and the VF are the same, but only when VI is 0. Only when VI is 0 is that true. So it's traveling at 19.6 meters per second after 2 seconds. How far has the bag fallen? We are asked to find the distance. Alana, the only formula that has distance in it is which one? That's the one. But we don't have V bar, do we, Vinny? How do you find V bar? Is there another one with V bar in it? Yeah. There sure is. It's VI plus VF all over 2. The initial is 0. The final velocity is minus 19.6 divided by 2. We just multiply by 2, and now we're going to divide by 2, and we're going to get minus 9.8. Now that's just a coincidence, because it's 2 because of the average thing, right? And it was 2 before because of 2 seconds. So the average speed is minus 9.8. Got that, Anna? So now to find out how far the bag has fallen, now we're going to go V bar equals D over T. And what's that V bar again? Minus 9.8. And guess what we're going to end up doing? What's the time? 2. We're going to multiply by 2 again, and we're going to get minus 19.6. And some of you might say, well, why did we bother doing all that when we ended up with the same thing as we had before? Well, this 19.6 is actually, it's a speed, it's in meters per second, and this is minus 19.6 meters. So the bag has fallen 20 meters in that 2-second period. How much do you think I would make a question like that worth on a test? Probably 4. 4 steps. Is that too much? 3 then, Jason? Okay. That question, or a similar one, will appear on the test. Now, what happens if the helicopter is already moving to begin with? I see some people still writing, so I'll pause. Kyle is now flying the same helicopter, but it's rising at 5 meters per second when he releases the lunch bag. Let me just put the helicopter over here, right? So the helicopter is now rising. So you on the ground see the helicopter rising. What do you see the lunch bag doing? Does it just fall? Does it hover? Does it go up and then come down? What does it do, Trent? Just falls normal? What is the VI of the lunch bag? Is it?
Yeah.
It's inside the helicopter, is it not? Like, that's no different than me walking sideways at 5 meters per second and throwing the ball up. Thin Sharpie. How thin, Mervyn? Mega thin or just thin-ish? You want black? Take a look. If I'm walking across the classroom with the yellow Pac-Man and I throw it up, how come it lands right back in my hand? If my speed is not 5 meters per second, but if I'm walking, say, a meter per second, what's the speed of the ball right now? Meter per second, I throw it up. Does it maintain that meter per second as it goes across? Sure does. And that's why it ends up back in my hand. So the bag, the lunch bag here, when it's dropped, it actually starts rising at 5 meters per second, but it starts to slow down. How come? Because of gravity. And then it starts to fall. Okay? So the lunch bag itself actually does that kind of trip. That's what you see on the ground. Vinny, what's so interesting in the back there? Oh, that's just the route to Boggy Creek. Don't worry about it. Oh. Okay, so my point here is that the VI is not 0 anymore, it's 5. The steps are going to be exactly the same. So the first thing I'm going to do is I'm going to do all this. Is the delta V going to be exactly the same? Is that going to all be the same? And the answer is yes, because what has changed in there? Anything? Nothing has changed. Gravity has remained the same. Delta V has remained the same. Colby is completely distracted by the map of Boggy Creek. I know you're from out that way. It's not the best map, is it? Yeah, I agree. Trying to focus, Colby. Okay, so that's the same. What about the next step? Will all this be the same?
No.
Why not? Because the VI is not 0, is it? The VI is not 0. It's going to be VF minus a plus 5. And when that minus 5 goes to the other side and becomes plus 5, my VF is not going to be minus 19.6 anymore. It's going to be minus 14.6 meters per second, isn't it? It's going to be going slower than before. How come? Because it started off going up. So some of that 2 seconds is actually going up and then slowing down and then coming back down, right? It's actually only going to fall for maybe 1.5 seconds. So does that change anything? How far has the bag fallen? What about the next step? Is this the same? Is it the same step? Is it the same work? It is. It's the same steps, it's just not the same number. So instead of a VF of minus 19.6, the VF is minus 14.6, isn't it? And the VI is no longer 0. It's in fact 5. Right? And 5 minus 14.6, and then divide by 2. I know I have a calculator in here somewhere. 4.3?
No, 4.8.
4.8, that sounds about right. Minus 4.8? I think so, right? 5 plus a minus 14.6, and then divide by 2, so that's going to be minus 4.8 meters per second. How can the average be negative when it starts out positive? Can that be? Sure, it just means that it's negative for longer, right? The overall average can be negative. So it's still going down. How far below the helicopter is the bag? Oh, I haven't finished it. How far has the bag fallen? Is this step going to be the same? The work's going to be the same. Instead of my average of minus 9.8, my average is minus 4.8, not 4.9. The time is still 2. What's the d? The displacement. That's going to be minus 9.6, right?
Yeah.
Minus 9.6 meters. It's going to fall 9.6 meters down. I'm actually getting a little hot. And a little fuzzy too, probably. Okay, but now there's one more question. How far below the helicopter's bag? Because the bag has gone up and down, right? And this distance here is going to be how much? Minus 9.6. But in the meantime, Lane, what's the helicopter doing? Going up. The helicopter's going up, isn't it? At how much? 5 meters per second. So the helicopter, v bar equals d over t. The helicopter is traveling at 5. Put a 2 down there. The helicopter rises 10 meters. This distance here is 10 meters. And now the question, how far below the bag, how far below the helicopter is the bag? Well, if the helicopter went up 10, and the bag went down 9.6, what's the total distance? Now, can you get rid of that negative? What does that negative really mean? It just means down, and now I'm asking you how much distance is in between them, so it's just 10 plus 9.6, and hold on, 19.6 meters. Isn't that what it was before? How far did the bag fall? 19.6. How far is the bag away from the helicopter? 19.6. The same thing. Is that a fluke, do you think?
Yeah.
Does it seem fluky? It does seem a little fluky, doesn't it? Try number 9. It's exactly the same steps. Number 9 says, now the helicopter is falling at 5 meters per second as it releases the launch bag. Why don't you guys try that? It is literally exactly the same steps. Go. So what's going to be different in this one here? The only thing that's different is instead of the VI being plus 5, the VI is minus 5. Delta V is going to be the same. So instead of subtract 5 here, we're going to have subtract minus 5, which means you got plus 5 there, so when it goes to the other side, it becomes negative. So instead of minus 14.6, it's actually going to be exactly minus 24.6. The bag is actually traveling faster because it had a head start. It's already going negatively. It's already being pushed down. How far has the bag fallen? Same steps. Got to find the average. Exactly the same steps. Except now the VI is minus 5, and instead of minus 14.6, it's minus 24.6. And what's my average there, Vinny? I know you got it worked out. Minus 5 and minus 20, that's going to be 29.6. Add them together. It's going to be 14.8. Minus 14.8. And now how far has it fallen? Same steps. V bar equals d over t. The average velocity is not 4.8, it's 14.8. Right? And then you got to multiply by 2. 29.6. It fell 29.6. How come it falls farther this time? Because it's going faster. Right? It starts off going minus 5. It's going to go farther. And I think once again it asks, how far below the helicopter is the bag? Are the steps going to be the same? Yeah. Here's the helicopter's distance. Except instead of being plus 5, it's going to be minus 5. Right? Let me bring my helicopter. I can do it up here, I guess. I'll start it up here. Right? The helicopter falls how far? Oh, we haven't got that yet. The bag falls 29.6. So the bag's going to go from there to there. That distance there is 29.6. But the helicopter goes down to there. How far does it go down? Looks like it's going to be the same thing, isn't it? Oh, it's 10 meters. Negative 10. So if that's 29.6 and this is 10, what do you know? What's the number? This time you subtract 19.6 meters. It doesn't matter how fast you're going to give it, the separation is going to be the same. It's not a coincidence. It's always going to be like that. And the last question also says, what is common to the answers? There's two things that are common. The acceleration is the same, minus 9.8, and the distance between them, and that will always be the case. Okay? Why do I subtract 10 here? I hear a few people talking. Because we're going down, right? 29.6, subtract 10. Just look at the picture. Stop worrying about the math, right? If that distance from there to there is 29.6, and that distance there is 10, this red distance here is going to have to be 29.6 minus 10. Just look at it. Oh, yeah. Okay? That's all there is to it. Guaranteed, you're going to see a helicopter question. Make sure you know how to do them. Okay, I gave you pre-test number 3. I marked the ones from yesterday. I think I did. I'll go find them. I'll hand them back. That's pre-test number 2. You need number 3? Did I miss you guys? Oh, I must have went around the outside and missed.